In this video, I'm going to go through the solutions to the Unit 2 retest, which is the transformation of the functions. The first question is to simplify these rational expressions, and we also have to state any restrictions on the variable. By looking at the numerators, I can write x squared plus 5x plus 6. Since the coefficient of x squared is 1, I can use the sum and product. The two numbers that the product is 6, sum is 5, are 2 and 3. So I can write x plus 2 times x plus 3 over the denominator the same way. Since the coefficient is 1, two numbers, product is 2, sum is negative 3, or negative 1 and negative 2. So this is the first fraction. Then we have division, x plus 3, x minus 1 minus 6 over x plus 3. But before I go any further, I'm going to find the restrictions. The restrictions are x cannot be equal to 1, 2, and negative 3 because of the denominators. Now I'm going to flip the second fraction and change the division to multiplication. So I'm going to get x plus 3, x plus 2 divided by x minus 1, x minus 2 times x minus 1 over x plus 3 minus 6 over x plus 3. Again, I check the denominators. Since I'm not introducing any restrictions, again, the restrictions are 1, 2, negative 3, so nothing has changed. Now I can just go ahead and simplify. This x plus 3 goes with this x plus 3. This x minus 1 goes with the x minus 1 here. So I'm going to end up with x plus 2 over x minus 2 minus 6 over x plus 3. Now the common denominator between these two fraction is x minus 2 times x plus 3. Now looking at this one, since it's missing x plus 3, I'm going to multiply numerator and denominator by x plus 3. So I'm going to get x plus 2, x plus 3. Now with this fraction, x minus 2 is missing. So I'm going to multiply the numerator and denominator by x minus 2. And remember, there is a subtraction here. So I'm going to get negative 6 times x minus 2. Now again, I look at the denominator. There is no new restriction is added. So I'm just going to go ahead and simplify. I'm going to distribute these two brackets and also this one. I'm going to get x times x is x squared plus 3x plus 2x plus 6 minus 6x plus 12 over x minus 2 x plus 3. Now x squared, there is no like term, so I get x squared. 3x and 2x is 5x minus 6x gives me negative x, and 6 plus 12 gives me 18 over x minus 2 times x plus 3, and the restriction is also x cannot be equal to 1, 2, and negative 3. The next question is that consider the base function y equal f of x, and then based on all these functions here, I have to write what is happening to x coordinate and y coordinate. So I'm going to start with A. It says 2f of x. It is obvious that nothing happens to x coordinate, so I put a slash here. This means nothing happens to x coordinate. But the y coordinate is going to be multiplied by 2. So I'm going to write times 2. So y coordinate is going to be multiplied by 2. The next one, as you can see, the x coordinate is going to be multiplied by negative 1. So I'm going to say multiply by negative 1. But The y coordinate is not going to change, so I put a slash here. The next one, if you look at this one, the x coordinate is multiplied by 1 over 2 here. This means that your b value is 1 over 2. So the factor, if you remember, is going to be the flip of b. So this means that the x coordinate is multiplied by 2. You flip 1 over 2. And the y coordinate is multiplied by -1. The next one again, the x coordinate is here is 4 over 3. This means that b is 4 over 3. So you're going to multiply x by 3 over 4. And the y coordinate, you're just going to add 2 to it. And the last one, we see that the b coordinate, b value is 1, but the h value is 3. So this means that we're going to add 3 to x values. And the a value is 3, so we're going to multiply this one by 3. The next question says, given the relation 3, 1, 4, 1, 5, 5, 3, 4, 3, 2, state the inverse. The inverse, as we know, we're just going to switch x and y. So the inverse becomes 1, 3, 1, 4, 5, 5, 4, 3, and 2, 3. The next question is the inverse a function? If you look at this, you can see that our x values here, 1, 1, is repeated, so this means that this is not a function. The inverse is not a function. And if you look at even the function, the relation itself, the relation is also not a function because of 3, 3 here. State any invariant points. By definition, invariant points are the ones that do not change. The x and y values are not going to change. And the only point which x and y are not going to change is 5, 5. So that's why we say that the point 5, 5 is in an invariant point. The next question is saying that the function f of x is plotted here. We are supposed to plot the inverse function. To plot the inverse function, we are going to pick a few points here, and then we are going to flip the x and y coordinate and then plot the new ones. The points that I'm going to pick are here, 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 and also here. Okay, let's start with this point and going upward. This point, the coordinate is 0, -8. Then the next point, if you look at the graph, is going to be 2, 0. The point after that is 3, 1, which is the vertex. And the last point is 4, 0. The inverse of these points are -8 and 0, 0, 2, 1, 3, and 0, 4. Now, I zoomed in so we can look at the graph better. The first one that I have to plot is 0, 4. Now this means that the y coordinate is 4, so the point is here. The next point is 0, 2, which is going to be here. The next one is going to be 1, 3, which is going to be around here. And the last point is going to be off the chart, so approximately your inverse is going to look something like this one. This is going to be your inverse. Now the second part of the question says draw in and label the line of reflection. The line of reflection is y equal x, which is going to be a line like this one. So this is y equal x. Theoretically, we could also find the inverse using line of reflection, every point here you would just find the reflection of this line, this point underline y equal x, and get the corresponding points. But finding the points seems to be much easier. Now the next one says, is the inverse a function? As you can see, if I draw vertical lines, the vertical line crosses the inverse function at more than one point, so we can say that the inverse is not a function. The next question is, we have to match all these terms on the top, meaning these terms, with the definitions here, which is given. So let's go through all of them one by one. The first one says a transformation that results in the shift of an original figure with no change in shape. The correct answer is translation, so this is I. The next one says a transformation that results in x coordinate of every point growing. This means you have a horizontal stretch. Now horizontal stretch is B, so we're gonna write B. The next one is transformation that results in the y coordinate of every point growing, so this is a vertical stretch. This means that this one is J, so this is J. The next one is transformation that results in the coordinate of every point shrinking, y coordinate. So this means it's a compression, but vertical compression. So now if we look at this one, the vertical compression is E. So this is E. The property that f of A equal B, then f minus 1 B is equal to A. This is the inverse of a function, and the inverse of a function is A. So this is A. The next one, the quotient of two polynomials. This is the rational expression, which is C. The next one, points xy becomes minus x minus y. This means that you have a reflection in x and y axis, which is H. So this is H. The next one, points xy become x and negative y. This means that you have a reflection of y points. So this means that you have a reflection on the x-axis. So the reflection on the x-axis is going to be f, which is this one. The next one is transformation that results in the x-coordinate of every point shrinking. So this means a horizontal compression, and horizontal compression is G. And the last one, points xy becomes negative x and y. This means that you're reflecting about y-axis. So this is a reflection on the y-axis, which is going to be D. The next question says that you have two triangles with the same base represented by x. So I have two triangles. One is x, the other one is also x. But the height of the first one is x plus 1, and the height of the next one is x plus 3. The question is, what is the total area of the two triangles, which is going to be the area of this one plus the area of this guy. So area by definition is base times height divided by 2. So it's going to be x times x plus 1 divided by 2 plus x times x plus 3 divided by 2. Since they have the same numerator, I can add them, and at the same time I can distribute x inside because we have to simplify. So we get x squared plus x squared plus 3x. So we get 2x squared plus 4x over 2. Dividing numerator by denominator by 2, I get x squared plus 2x. Because this one, and this one, they can be simplified by 2. In the next question, we have function f of x, which has the vertices of negative 2, 2. Let's call this one A, this one B, and this one C. These are the vertices of the function. now we apply a transformation which is given by g of x equals 3f negative 2x plus 8 plus 1. We are supposed to draw the transform function. Before we do that, let's just plot these points. When for a is going to be negative 2 and 2, so this is a. For b is going to be 4 and negative 1, which is going to be here, so this is b. And c is going to be 6 and 2, which is going to be here. So this is our function. Now, we look at the transform function, you can see that I can write g of x is equal to 3f of, I factor negative 2 out, I get x minus 4 plus 1. Now I can easily see what a, b, h, and k are. So a is 3, b is negative 2, h is 4, and k is 1. So I can say that xy is going to be mapped to 1 over b times x, so it's going to be negative x over 2 plus 4, ay 3y plus 1. This is my mapping notation. Now, our original one, if we apply these transformation, every x is going to be multiplied by negative 1 divided by 2. So negative 2 times negative 1 is going to give you 1. 1 plus 4 is going to give me 5. Now 4, I look at this one. This is the original one. 4 times negative 1 is negative 4, divided by 2 is negative 2. And negative 2 plus 4 is going to give me 2. Again, I take this point, put it in this notation, expression, and then simplify. 6 times negative 1 over 2 gives me negative 3 plus 4 is 1. Now I do the same thing for the y coordinate of the original and put it here. So 2 times 3 is 6 plus 1 is 7. The next one is negative 1. Negative 1 times 3 is negative 3 plus 1 is negative 2. And the last one is 2. 2 times 3 is 6 plus 1 gives me 7. Now these are the table of value for the transform function. So I'm going to plot them. Remember, the first one represents a, b, c. So let's call this one a prime, b prime, and c prime. A prime says when x is 5, y is 7. So when x is 5, y is 7. So I'm going to get this point. This is my a prime. B prime says when x is 2, y is negative 2, which is b prime. And c prime says when x is 1, y is 7, which is going to be c prime. So this is the sketch of the transformed function. Now the last part of the problem says final vertices are 5 and 7, 2 and negative 2, and 1 and 7. The next question says if f of x is square root of x, first sketch it, then find the domain and range. So to sketch the first graph, which is the base function, I'm going to use a table of value x, y. I'm going to say when x is 0, square root of 0 is 0. When x is 1, square root of 1 is 1. When x is 4, square root of 4 is 2. And that's enough to plot the graph at the moment. Now, when x is 0, y is 0 is going to be here. When x is 1, y is 1, which is going to be here. When x is 2, when x is 4, y is 2, which is going to be here. So my graph for the base function looks like this one. The next one says if g of x is f of negative x plus 2. Oh, before I do that one, let's talk about the domain and range here. you can see that the base function, the domain, is x in R, and x has to be greater than or equal to 0. The range is y in R, and y has to be greater than or equal to 0. The next one is g of x, which is f of negative x plus 2. I can easily see that the g of x, a is equal to 1, b is equal to negative 1, h is 0, and k is equal to 2. So my mapping notation becomes negative x, 1 over b is 1 over negative 1, which is negative 1 times x is negative x, plus h is 0, ay, which is going to be y plus 2. So my transform table of value now is that I'm going to apply these to my original table of value. So when x is 0, negative 0 is 0. When x is 1, negative 1 is negative 1. When x is 4, this one is negative 4. We do the same thing for the y coordinate. We say that for every y, we add 2 to it. So 0 plus 2 gives me 2. 1 plus 2 gives me 3. And 2 plus 2 gives me 4. Now let's plot this. When x is 0, y is 2, which is going to be this point. When x is negative 1, y is 3. So when x is negative 1, y is 3, which is going to be this point. And when x is negative 4, y is 4, which is going to be somewhere around here. So I can just connect these together and I get a graph like this one. This represents g of x. Now by looking at the graph, you can see that the domain is x in R, and x has to be less than or equal to 0. Your range is y in R, and y has to be greater than or equal to 2, because y goes upward greater than 2. The next function, h of x, by looking at the function, you can see that your a is negative 1, b is 1, h is negative 1 because it's x minus h, and k is 2. So our mapping notation becomes 1 over b, which is 1, so x minus 1, and minus y, ay is negative y plus 2. So this means that our table of values, we just subtract 1 from our base table of value here. So 0 minus 1 gives me negative 1, 1 minus 1 gives me 0, and 4 minus 1 gives me 3. For the y, we multiply the base by negative 1 plus 2. So 0 times negative 1 is 0 plus 2 is 2. 1 times negative 1 gives me negative 1 plus 2 gives me 1. And 2 times negative 1 is negative 2. Negative 2 plus 2 gives me 0. So now I'm going to plot these points. When x is negative 1, y is 2. So I get a point here. When x is 0, y is 1. So I get a point here. And when x is 3, y is 0. So it's going to be this point. Now if you plot this one, you're going to get a graph like this. Now the domain is going to be x in R, and x has to be greater than or equal to negative 1, and your range is going to be y in R, and if you look at it, your range is going to be less than or equal this value here, which is 2. So your range is going to be y less than or equal to 2. The last question is to find the inverse of the following equations. The first one is y is equal to negative 1 over 3x plus 4. I'm going to isolate x by moving 4, so I'm going to get negative 3x is equal to y minus 4. I multiply both sides by negative 3 to get rid of the 3 and also negative, so I get x is equal to negative 3y plus 12. And that's it. Since I isolated x, now I can write f minus 1 is negative 3x plus 12. We just substitute x with f minus 1 and y with x. The next one is y is equal to 7 times x minus 3 squared plus 2. Again, I'm trying to isolate, so I'm going to move 2 to the left. I get 7 times x minus 3 squared is y minus 2. I divide both sides by 7. I get y minus 2 over 7. I take the square root, but remember square root is going to give you plus or minus, so I'm going to get x minus 3 is plus or minus square root of y minus 2 over 7. I'm going to move x to the right. I get x is 3 plus or minus y minus 2 over 7. Now I replace f with x with f minus 1 and y with x. And that's it.